On planet Earth, with ice-capped mountains enmeshed with forestry and deep blue oceans thriving with life, a child is wondering about how division works.
What is divisibility?
A number's capability to be divided that gives a whole number.
What are the main divisibility rules and how do they work?
A number is divisible by 2, if the last digit is even. Any number can be written in the form A0, the units can be easily seen if whether they are divisible by 2. A1, the tens can be written in the form A2, the hundreds can be written in the form. Based on this we can say these values can be written congruent to 0 mod 2. Therefore we can conclude any number is divisible by 2 if, and only if the last digit is divisible by 2.
Computer, what is modulo?
Note: A is congruent to B mod C means that C is a factor of A minus B.
You said there's a divisibility rule for 2, is there one for 3?
A number is divisible by 3 if the sum of all the digits is divisible by 3. Suppose base 10 representation of a number x, shown on the screen. We know 10 is congruent to 1 mod 3, therefore 10 to the power of n is congruent to 1 to the power of n mod 3 for all n, which means 10 to the n is congruent to 1 mod 3 for all n. Using basic properties of congruence we can say, this is to say the difference between a number x and the sum of its digits is a multiple of 3. Therefore a number is a multiple of 3 if and only if the sums of its digits is also a multiple of 3.
What about 5? Is there a rule for that?
A number is divisible by 5 if the last digit is either 5 or 0. Let a be an integer with digits in the form shown on the screen. We can rewrite a in the form shown, which is equal to. And then we can deduce that since 5 is a factor of 10, the divisibility of a depends on the final digit as shown on the screen.
What about other numbers? Do they have divisibility rules?
There are more rules for divisibility, as shown, and these can be proved in similar ways using modular arithmetic.
So is there any general rule we can use for any number?
Yes, we know that a prime number is one that only has divisors which are 1 and itself. A composite number is one that has at least one positive divisor apart from 1 and itself. If our test number, n, is prime, then its only divisor apart from 1 is itself. So for a general divisibility rule using any test number n and divisor d, first split n up into its prime factors, as shown. Let p1 be the smallest factor of n, such that p1 lies strictly between 1 and n. Since p1 is the smallest factor, then it must be prime, otherwise there would be a factor of n which was smaller. The proof is shown on the screen.
Thousands of light years away, on a strange aquatic planet known as Camino, some creatures known as Caminonans have 3 fingers on each hand, and the counting system has only 6 digits: 0, 1, 2, 3, 4 and 5.
But what about us? We Caminoans only have 3 fingers on each hand, so we count in number base 6. Are our divisibility rules the same as yours on Earth?
All number bases have their own rules, so yours will be slightly different to Earth's.
How about our divisibility rule for 5?
A number is divisible by 5 if the sum of the digits is divisible by 5. Let any number b have digits in the form shown on the screen. Then b can be written in the form shown. And we can prove using modular arithmetic that 10 to the power of k, minus 1, is a multiple of 5 for any k. Hence, the first expression is divisible by 5 as shown, so we can show using algebra that the divisibility of b by 5 depends on the divisibility of the sum of the digits of b.
What about 11? Is there a divisibility rule for that?
A number is divisible by 11 if you add and subtract the digits in an alternating pattern. Take any number b with digits in the form shown on the screen. Then we can rewrite b in the form shown. We can raise this to the power of n and see that the remainders for each digit will either be 1 or minus 1 when divided by 11, as shown on the screen.
Are there any rules for 2, 4, 5 and 10?
We can get other divisibility for primes such as the ones shown on the screen, and these can also be proved in similar ways using modular arithmetic in base 6.
Is there a general divisibility rule for our number system?
You break each number down into its prime factors. So 452 breaks down into the factors shown on the screen. Since the prime factors of the divisor are a subset of the prime factors of the dividend, then we can see that 452 is divisible by 34. No, but we can use the general divisibility rule of prime factorization similar to Earth but with base 6 instead, and then use the divisibility tests. Other rules for primes can be easily established using modular arithmetic. For example, we can easily establish a proof for the prime number 15. Hence, we have established a proof for divisibility by the prime number 15 base 6, where if this value is divisible by 15, the original number is divisible by 15. We can create similar rules for other base 6 numbers and can also use similar ideas for base k numbers, where k belongs to the set of natural numbers.